The nitrogen cycle. Nitrogen is the most abundant element in the atmosphere, coming in around 78% of the composition. So, the atmosphere is where we start our journey. Nitrogen in the atmosphere can be processed by nitrogen-fixing bacteria within the soil, bacteria that take in gaseous nitrogen and convert it into a solid state, placing it in the soil. From here, plant roots can absorb the nitrates as vital nutrients for survival by the process of assimilation. Animals will then consume the plants for energy. Animals can defecate, pee or poop, which contains the nitrogen that they consumed and are done with. Fast forward. Plants and animals cannot live forever. The organic matter from the dead plants and animals alongside the fecal matter from other living organisms is all swarmed by decomposers such as fungi, worms, or bacteria. This decaying matter is changed into ammonia, NH3. From here, underground nitrite bacteria go to work and convert this ammonia into nitrite, NO2. It is then passed on to nitrate bacteria, who turn the nitrites into nitrates, NO3 molecules, where it can be then reused by plants. However, underground denitrifying bacteria can remove the oxygen from those nitrates, leaving nitrogen gas as the product, which can rise back up to the atmosphere, replenishing the atmospheric supply. Now that we are back in the atmosphere, we can take another travel approach for nitrogen. Humans use nitrogen as fertilizer because, as we learned before, it is very beneficial for plants. This fertilizer is used and then can take one of two routes. It can seep into runoff, taking shelter and surface water, later bringing it to the ocean where it can seep back into the ground and be accessed by denitrified bacteria yet again. It can also seep directly from the soil into the ground. This fertilizer, in the site of ammonia, or nitrates, can be accessed by nitrate bacteria, denitrifying bacteria, or can infiltrate the groundwater and eventually wind up back in the ocean. Nitrogen gas can also enter the ground through one more route: lightning. Nitrogen fixation can occur when lightning strikes. Once this process happens, the nitrates can be used by plants. Lastly, the final way that nitrogen gas can re-enter the atmosphere is by fire. A plant catching fire will release nitrogen gas through the process of combustion. In the case of our ego column, nitrogen was passed the same as it would in any other setting. Excess nitrogen is taken in by the nitrogen-fixing bacteria in the soil, making it usable for the plant that we place in our terrestrial tube. The plant would not be able to live without nitrogen, as nitrogen is vital for the creation of chlorophyll, the key component in photosynthesis. After the plant dies, the excess nitrogen will be decomposed. However, we have a decomposition chamber that is processing nitrates already. Crumbling leaves show us the decomposition that is going on. The decomposed nitrates are turned into ammonia and seep into the aquatic chamber below. There, the algae can absorb the nitrogen compound to become nutrient-rich by the process of assimilation. The fish that feed on the algae are then ingesting the nitrogen compounds that were within the plants. Once the fish die, the process of ammonification, in which the ammonia molecules from dead animals are oxidized back into nitrates. Fish waste and carcasses produce toxic ammonia. Ammonification detoxes that ammonia so living organisms are not killed by it. From here, denitrifying bacteria back in the terrestrial chamber will begin to break down the nitrogen molecules from the oxygen molecules, sending a pure nitrogen gas swirling near the top of the column waiting to be reused.